Alright, say for 95 for extra kind of tips. Now, question is, okay, everything geometry is simple. Oh, simple enough, yes, but not all building is simple. Your current design architect, they always try to do something more unique, right? So I'm gonna give you just other kind of it's not a trick, but I think something is a graphically geometry how to do it a more efficient way. I think worth it to learn, right? So one thing that there are few occasion. So I'm gonna just choose. What if we have? I'm gonna choose all the pin and composite beam I'm gonna use. So what if we have like this, right? Or what if we have? Let's say I may have to made it up. Something like this. I mean, those are all structural planning, layout, and just our expertise how to handle the geometry. So sometimes you could add more grid, or sometimes reference line. You have to use it and provide, and you can draw all the beams. So here, assume that you have this kind of chamfer corner. How are you gonna draw this, right? Because you don't have you basically in order to do this you need a point here. But the thing is ETABS has some great snap tool. So when you kind of click and move this, the color changes to yellow, green. So right click, then basically you draw the beam more parallel. So you typically I cannot exactly hard to find out this intersection point. So I draw this the beam which actually cross over. I select all this beam, right? This two beam, and go to edit and edit frame. There is a divide frame. So let ETABS gonna find that intersection point. So right, so this one should have an intersection point. Let's check it. Yep. So I delete this. I'm gonna delete this. Right. So when you delete it, the problem is okay. This one also segmented. Right. This coder is segmented. I prepare to just click and go to edit frame and join them. So this is one member. Since I use intersection, I lost the boundary condition moment release. So I'm gonna click and select apply, go to frame, go to end release and assign the end release. So this is beam is shorter, but right gets shortens, but frame into this diagonal beams, right? All right, if you don't know, this is kind of annoying because obviously we are talking about productability and efficiencies. The geometry kind of developing skill is really it's not engineering skill. This is just common. It's all about your how many times you try to learn and exercise. So our solution for the drawing the geometry, it doesn't have to be always 1, 2, 3, 4, 5. Sometimes it's 1, 10, 7, 8. I'm sure the engineer or humans always choose different route, but you should be able to always get to the destination, like right, the boundary condition and beam intersection point and merging, so that you can clean up, develop the all the proper modeling, right? All right, maybe sometimes here I don't see this intersection point. Maybe let's assume maybe you don't have to use this, but at this point, I'll choose any random section property. I'm gonna draw it just for your explanations. So let's say if I have to draw something like the this kind of I need to see turn on the node. No, join. Okay. So let's say if I have to do something like that. Okay, right? I think it's the last class so we talk about something non-typical. So let's say if you have this situation, right? obviously you may end up with this, or this is cantilever beam and this cantilever beam, this is too long. So something you end up with the sudden the different approach. But here I'll assume adding this column here. So this one is a girder, so I need to make moment release. So this one, okay, tied together. This beam is obviously spanning from here to here, but this one is cantilever. So under this, we need to have, we should not have the moment release. So because of this cantilever, I'll just leave it. So moment release, moment connection. And typically when we have a moment beam, we need a backspan has also moment connected here on the right. So I'm gonna select and okay, remove the moment release here. So this case is all gravity loading is coming in this bay to beam and go other and beam to beam. But here this beam dump the loading each end, but at the top the beam reaction should be taken by this girder cantilever, right? So sometimes if you have this condition, this is a little bit next step of so but you need to just learn a little bit more some strategy how to deal with this. It depends on your kind of structural planning. If we have a column, it's no issue. I'll just make this all moment release, simply support, right? So this is normal framing, right? All right, but this might be a little bit too long. Too long. Worst case, I'm gonna add the one more composite beam here in the middle point. It doesn't pop up my snap tool. Okay, snap up. This screen is always too small. Okay. All right. Somehow. Okay, I'm gonna divide it. So this case, because there is a snap tool, but it doesn't show me. Okay, so I divide it, and if ETABS can snip, but sometimes this is kind of dangerous. Doesn't sometimes it's accurate, so hopefully this is connected. Okay, so I can add another beam here because I told you that typically metal decks span is about 10 feet. So beam and beam, and we have a little bit less than 10 feet spacing of the beam. All right, so this is kind of a variation you need to know. Maybe I can add another beam here too, if this is the case. In this case, again, I'm gonna divide this to okay. Oh, I didn't assign I didn't choose the pin connection. What? Come on, release. All right. Okay. So now still these cases we have all beam framing is kind of parallel to north south. Did I delete the slab? Okay. So this case, what you can do is you need to draw the metal deck slab by clicking each corner where your slab geometry changes. Okay, I click double. So I'm gonna redraw it. Click this. All right. So same method. Oh. Where'd you go? Oh, maybe did I turn off? Oh, I turn off. Oh, okay, old one is hidden. Okay. So this one again, in reality, it depends on your project. I'll expand, right? 24 inches, it depends on. So there's no issue. I think ETABS is well advanced now, help user to manipulate their geometry more kind of simple way. All right. So this is one. But now one more thing I try to show you. Let's say if you end up to somehow choose the other beam orientations the other way. So let's say here, right? So now you have some common sense. You cannot run the metal deck is in this direction. Should be always perpendicular direction, right? So engineer, you may have to choose the slab profile, and you need to draw separately. So this one is spanning this direction perpendicular to your beams, and the other one, right, your local axis, now 0 is default running left and right, but 90 degrees is running 90 degrees, right? So you see that most of floors slab metal deck orientation should be running perpendicular left and right, but if you happen to frame like this different direction, you need to segment it, and then you have to redraw no draw the separately so that the metal deck is running opposite direction. Okay, so this I would say this is everything that you need to practice. No matter what any building you are given, you should be able to draw all this column beam girder and moment release and slab, draw the slab and boundary condition and assign the loading and analyze it. And okay, let's run this model and see. Since I redrew the slab, I don't have any loading. We'll just check the self-weight deflection only. Moment diagram. Okay, got it. I just show you the self-weight moment diagram. Download the diagram. See the all simply supported one single curvature moment diagram, right? And the show force diagram should be same, like a uniform, the constant on the sloping the shear force diagram, right? Good. So I'm gonna stop here.